So just goofing around there. I don't know what I played, but it sounded kind of cool. All right. So let's see. We're going to move on a little bit with some more derivative rules in part 2 of my video here. So let's start with the constant multiple property. All right. And you'll use this all the time. Okay. The idea is if you have a constant, k is a constant, and it's multiplied by a function, when you do the derivative, you just sort of ignore the k and write it down, and you multiply it by the derivative. So an example of that would be something like this. Say that you have y equals 2 times x to the 4th. So the way you would do the derivative is you would just write down the 2, don't do anything with it, and then multiply by the derivative of x to the 4th, which we know is 4x to the 3rd. So you would get 8x to the 3rd power like that. That's what that property is saying. A constant multiplied by a function. Don't differentiate the constant, just write it down. Okay, and then multiply by the derivative of the function. All right, so what we'll do is we'll do a little proof of this. So I'd like to kind of show you how mathematicians figure this great stuff out. So our function is k times f of x. All right, so what we're going to do is we're just going to put this in the wonderful difference quotient. So we have the limit as h goes to 0 of f of x plus h minus f of x all over h. And we're going to get everything set up here. All right, so again, the way I've been teaching you all to do this is like this, is just start, kind of build the framework when you put together the limit like that. Just bracket minus bracket over h. All right, now remember, f of x goes there, so f of x is what I gave you. Now I'm just writing this as a general function. That's the power of algebra and variables, is we can just represent it by something. So we get k times f of x will go there, okay? So now the next thing is we do f of x plus h. Well, like we've learned here, it's the same, one little exception, x becomes x plus h. So you still have the k. Now you have f of x plus h. So that's how that thing would get set up in the difference quotient and the definition of the derivative. Now the next thing is k is a factor. Just algebra, you can pull that k out of there, so you would get the limit as h goes to 0 of k times f of x plus h minus f of x all over h. All right, now remember all those great limit properties we learned? Well, there was a limit property that said we can pull a constant out of a limit. So when you have a constant multiplied by something in a limit, that can be pulled out. So you would get k times the limit, h goes to 0 of f of x plus h minus f of x all over h. So my question to you is, well, we have k, but what is this thing right here? What is that whole thing right there? That is the definition of a derivative. So you get k prime, f prime of x. So see, I just proved that. Okay, this right here is equal to this. Okay, when you do the derivative, you're going to get this. All right, so that's what I showed you. All right. Okay, so let's move to the next page, and now we're going to look at the sum difference property, and we'll also do a proof on that. So the sum difference property says if you have two functions that are added or subtracted, if you want to do the derivative, you just do the derivative of each part and then add or subtract. So an example of this would be something, let's do something real simple, like let's say, let's just say x to the 5th plus, and let's say 12. Okay, by this property, what you would do is you would just do the derivative of x to the 5th, which is 5x to the 4th. Then you would do the derivative of 12, which is 0, and then you would add them together. So you just do each piece separately is what you do. If that was a minus sign, that would just stay a minus sign. So you would end up getting 5x to the 4th for your derivative. Okay, let us prove. All right, so what we have is y. Let's just write this as f of x. Now let's just go ahead and write plus minus g of x like that. So again, what we're going to do is we're going to plug into the difference quotient. So the definition of derivative, again, is limit as h goes to 0 of f of x plus h minus f of x all over h like this. Okay? Okay, so the next thing I'm going to do is we're going to do this. We're going to set this up in exactly the same way we've been learning how to do this. So we're going to kind of have bracket minus bracket all over h. I'll do exactly the same thing I've been showing you over and over again. F of x goes here. Well, that's what the whole function is. That whole entire function is f of x plus or minus g of x. Like that. So that's what it is. That's what we're starting with. Then f of x plus h goes here. So it's going to be exactly the same thing as this with what difference? The x changes into x plus h. So we'll have f of x plus h plus or minus g of x plus h like that. And that's how that would get set up in the difference quotient. Well, what you'd have to do is kind of rearrange all this stuff. So what you would actually have is if you rearrange this, I may not show every little step of this, but we could do the f and we can put the f's together. So we would have f of x plus h minus f of x. Okay, like that. Then we would kind of have plus or minus, and then we would have g of x plus h, and then minus this. Okay, now don't really worry too much so much about the minus there, right there, because the idea is you're just subtracting whatever that value is. So you would have this all over h then. All right, so you can break that up like this. All right, so the idea of this then would end up being this. You could break this up like this then. So you would end up getting the limit. H goes to 0, and then you could break this up kind of like this. You could break it up as f of x plus h minus f of x over h, and then plus or minus, and then you could have another limit, or I'm sorry, I'm not ready for a limit yet, so we could have g of x plus h minus g of x all over h. And that's just doing some fundamental algebra. I'm just sort of splitting it apart, the fraction apart. Well, what we do is remember what we learned is the limit of a sum is the sum of the limits. So we could actually just write this now as the limit h goes to 0, f of x plus h minus f of x all over h plus or minus, and then another limit h goes to 0 of g of x plus h minus g of x all over h like that. Now what I did is I'm applying a limit law. So, you have to learn limits before you learn derivatives. These derivative rules are intimately tied to the idea of limits. So what is this big thing right here? That is the definition of f prime of x. What is this big thing here? That's the definition of g prime of x. So isn't that cool? So I just showed you that this derivative of this gives this. All right, so that's how you would verify that. That's how a mathematician would verify that that is correct. All right, so what we're going to do is use this property to crunch out some derivatives down below here then. Okay, now a lot of these things you don't have to write all the steps I'm doing, but I'm going to write all the steps on these examples because I'm trying to teach you what the rules say. But yeah, you'll be able to do a lot of these in your head, and I'll show you that as we go. So if you're doing the derivative of this, y prime, this would be the constant multiple property. So you have a constant times a function. The constant's -3, the function's x to the 4th. So the way you do this is you simply write down that function, or that constant, then you do the derivative of this, which would be 4x to the 3rd, like that. Okay, then you just multiply this together, so you get -12x to the 3rd would be the value of that derivative then. Okay. In practice, you're probably not going to do it that way. Probably what you're going to do is just 4 times -3 is -12, and then you subtract 1 from the exponent to get x to the 3rd. Okay, but it's the constant multiple property that allows you to do that. Okay, this one we have f of x equals 1/2 square root of x. So what do you have to do with the square root of x? You have to rewrite that as x to the 1/2 power so that you can use the power rule. Okay, so now this goes like this. You have f prime of x, and against the same situation, 1/2 is a constant, x to the 1/2 is a function. So you write down the 1/2, multiplied, then you do the derivative of this guy right here, so that's 1/2 x to the 1/2 minus 1, like I showed you earlier, and then this is going to give you 1/4, when you multiply that, times x to the negative 1/2. Now that's your derivative, but again, a rule of thumb I was talking about, if you start with a radical, you probably want to end with a radical. So we could write this as 1/4 x to the 1/2, then change that over to a square root to get 1/4 times the square root of x. So that would be as far as you would want to take that derivative there. You don't have to rationalize a denominator or anything. That's good enough. Okay? All right? Now, these are sums and differences on this. So the way you would do this, and again, this Leibniz notation, this just means take the derivative of this function with respect to x. Variables got to match. See, this is d dz, we have z's. So it would go like this, and we're going to write steps that you're probably not going to have to do because you're going to do this whole problem in your head. So what we have is d dx, we're going to do the derivative of the first thing, and then plus the derivative of the second thing, which is x, and then minus the derivative of the next thing, which is 7. Okay, so that's what that sum difference property says that we can do. Then this is a constant multiple right here. So you could, when you do this derivative, you can actually just say 2 times the derivative of x to the second. Okay, then we do these derivatives. Derivative of x is 1. Let me explain. There's 2 ways to look at that. Technically, that's x to the first. So if you did the power rule, it would go like this. You would go 1 times x to the 1 minus 1. So that's 1x to the 0. But x to the 0 is 1, so you just get 1. That's one way to look at that. The other way to look at this is, hey, y equals x is a line with a slope of 1. So anytime you do the derivative of 1x, it's 1. If you do the derivative of 2x, it's 2, and so forth. So that would be 1. The derivative of a constant is 0. So that derivative of 7 is 0. So you would actually have as your answer 2x, we have to do the derivative of x to the second. So the derivative of x to the second is 2x to the first plus 1. So your answer to this problem would be 4x plus 1. You will begin to do this problem in your head. You're not going to have to write these steps out. What you're going to end up doing is just, okay, power rule. 2 times 2 is 4, 4x to the first. Derivative of x is 1, derivative of 7 is 0, so you'll be doing that kind of problem mostly just in your head, okay? But we're demonstrating the properties right now. Okay, next problem, we're doing a derivative of z with respect to the variable z. So again, we're going to do this. We're going to do the derivative of the first function, 5z to the 4th over 2, plus the derivative of the second function, 3z to the 2nd over 4, like that. Now what you have is a constant. Sometimes students don't understand fractions real clearly, but this is really 5/2 times z to the 4th. It's the same thing. And then this is really d over dz. This is 3/4, the constant, times z to the 2nd. They're the same thing. So you could do this constant multiple rule. You could write this as 5/2 times the derivative of z to the 4th plus 3/4 times the derivative of z squared. Okay, and again, this is a problem that mostly you'll just do in your head or with a couple of steps on your paper, but this is the way that you use these properties. So now what you would do is you'd bring down the 5/2. When you do the derivative of z to the 4th, that is 4z to the 3rd and you still have your plus sign. Bring down the 3/4. And when you do the derivative of z to the second, that's 2z. Okay, like that. All right. Now what you do is you multiply out the fractions. Okay, and again, this is just over 1, so that would be 20 over 2 z to the third. That would be over 1, so that would be 6/4 times z. And then you can reduce those fractions. So this would be 10 z to the third, and that would be 3 over 2z. Okay, so that would be the best way to write the answer of that derivative, is like that. A couple of things you could have done differently here. Of course, you can do this. 4 over 2 is 2. 2 times 5 is 10. 2/4 is a half, so that gives you 3/2. You can reduce before you multiply out like that. So that would be the idea of how you're using these properties to figure out that derivative. We have the basic derivative rules, but we're going to build on that, and the derivatives are going to get a little more complicated as we go. Okay, I'm going to do 2 more examples, and I'll put you to work on a few of these and just see what you get. Okay, again, trying to write the steps as we're learning this. So g prime of x, since we have 2 functions subtracted, what we'd really do is we'd do this. Now I'm going to write this like this. I'm going to use the Leibniz notation. So I'm going to say d dx of 3x minus d dx of 4. Now I'm kind of doing 2 notations at the same time. Some people would really gripe at me for doing that, but I want you to see the point. I guess the best way probably to write this is just totally in Leibniz notation. Say dy over dx is equal to this. I just kind of like Leibniz notation a lot. Sometimes you'll see a textbook write this like this. They might say 3x prime minus 4 prime. I see that a lot. I just am not used to writing it that way, but you could if you wanted to. So I'm going to write this as 3 times the derivative of x. And then the derivative of 4 is 0 because it's a constant. Okay, and then the derivative of x is 1. So you'd have 3 minus 0. That derivative would be 3. Now that problem right there, you're not going to typically go over that. This is a line. That's y equals mx plus b. So the slope of the tangent line is going to be equal to 3. You can do that in your head. Boom. 1 second and you're done. Okay, that's the idea. Okay. All right, let's do this next one. This one's just got some rational exponents in it and stuff. Okay, so I'm going to write this in Leibniz notation this way. Now you can write y prime, or you can write dy over dx. Okay, like that. That's kind of the standard Leibniz notation. I'm going to use Leibniz notation. That's what I use most of the time. So what I'm going to do is I'm going to do the derivative of the first term minus the derivative. And let's just go ahead and let's skip a step here. I'm okay with this. We have a constant, so you could say 2 times the derivative of x to the 3/2 plus 3 times the derivative of x to the third, and then minus the derivative of 4. Now that's a lot of writing. Like I said, in practice, you're not going to really write it out this way. You're just going to do each piece in your head, primarily. Okay, so what you would end up having is just start doing your derivatives. This is power rule, so that's negative 2/3 x to the negative 2/3 minus 3/3. You can start doing that in your head. You get negative 5/3. The next piece, just write down the constant 2. Power rule, this would be 3/2 x to the 3/2 minus 2/2. And then the next one, write your constant down 3. The derivative of x to the third is 3x to the second. And what's the derivative of 4? That's a constant, so that's 0. Now this problem we're just going to, I usually try to match what the original problem had. The original problem had a negative exponent in, so I'm just going to leave my answer with negative exponents. So this is going to be negative 2/3 x to the negative 5/3. So what that is, see the 2's cross out because that's really 2 over 1. So it's minus 3 x to the positive 1/2, and then plus 9x to the second. Okay, so that would be your derivative. That form is okay on that. You don't have to change it really to a positive exponent and radicals unless you're specified to do so. Okay, so that'll kind of get you started on that. So the next thing I'm going to have you do is we're going to pause the video. We're going to run through these 8 problems at the bottom of the page then. Okay, so please do these. Don't, just copy what I do. Just try to do these yourself. Learn a little bit better that way. See if you're responding to my teaching. Okay, good. Okay, moment of truth. Let's see how we did here. Check your answers on this. I'll just kind of briefly go through these, and you may need to pause the video if you made some mistakes and need to think about what you did wrong. If you did anything wrong. A lot of these things can be done in your head. The way I was kind of writing the steps on these, though, was basically showing the rules. So you can just, that's a constant. Charles, a constant, write it down. The derivative of x to the fourth is 4x to the third. Therefore, you get 48x to the third. Now, again, you can do it in your head. You can just write your answer on that, all right? Don't require you to show work on that. Same thing here. 5/8 is a constant, write it down. The derivative of x to the fourth is 4x to the third. You can reduce the fraction, so you get 5 over 2x to the third. And this can be written one of two ways. These are both the same thing. 5 halves x to the third or 5x to the 3 over 2. They're the same thing. They mean exactly the same thing, right? The next one's 9. And see, you can think of this as a linear function. Y equals mx plus b. It has a y-intercept of 0. It has a slope of 9. Therefore, the derivative is 9 always. You have a linear function, it's just the slope of the line. Okay? This one I rewrote this way, x to 1/2. Then I just did power rule. So 1/2 is a constant. I wrote it down. Then 1/2, bring down the half, subtract 1 from the exponent to get this. I changed that to a positive exponent, and then back to a radical. All right? I think I already did that problem. That problem looks real familiar to me. Deja vu. You ever heard of Vuja Day? There's deja vu, and then there's Vuja Day. Vuja Day means the feeling that none of this has ever happened before. Okay, number 5. I would write this like this: 1/9, and that's x to the 2/3. Okay, that's how I do that, and then just do 1/9 is a constant, and then 2/3 x to the 2/3 minus 3/3 would give this. Make the exponent positive, change it back to a radical. Okay, and then the next one, 2 is a constant, write it down. Derivative of x to the 8th is 8x to the 7th, plus 8 is a constant, write it down. Derivative of x squared is 2x to the 1st, and then the derivative of x is 1. Okay, don't forget that. I keep kind of reminding you of that. That's a line, so the slope's -1. Okay, so that's the answer. You can do that totally in your head. Problem 7. 2/3 is a constant, write it down. Derivative of x to the 9th is 9x to the 8th. Notice that the 9 over 3 is 3. 2 times 3 is 6. And then 1/4 is a constant, write it down. Derivative of x to the 8th is 8x to the 7th. And then 8 over 4 is 2. Now I wonder on this thing right here, I wonder how many people messed up on this. I see this all the time. I wouldn't be surprised if a few students went 2 times 5e to the 4th and got 10e to the 4th. Why is that wrong? Because e is a constant. Okay, I almost always put that kind of thing somewhere on a test because I want to make sure students understand that e is a constant. Okay, so don't fall for that. Okay, if you did, don't do it again. Be careful. Okay. And the next one, we write this as 2t to the half minus t plus 2. Derivative goes like this. Write the 2 down since it's a constant. Power rule, you're going to have 1/2 t to the 1/2 minus 1. Derivative of t is -1. Derivative of the constant 2 is 0. So you end up getting this. Make the exponent positive. Change it back to a radical. Okay? So this is kind of a good place to pause if you need to on here, because this is what I mostly want you to know how to do, is the constant multiple rule and the sum difference rule for derivatives. Okay, and then we're going to move to the next page and kind of expand on this idea a little bit. Okay, so let's push on from here. And on the next page, let's see, we'll do a few things with differences and quotients. Okay, so I want to go through some products here. Now, what we're going to learn first of all, when you're doing this kind of a derivative, you're probably wise to just multiply this stuff out. You can't just do the derivative of 2x and then do the derivative of the parentheses and multiply together. That doesn't work. You're going to learn something in calculus called the product rule. I'll teach that at the very end of this section, but we're not ready to do that yet. Just distribute. Okay, so go ahead and just do the distributive property first. So you have g of x equals 2x to the fourth power minus 8 x to the second power and then plus 4x. Now do your derivative. Okay, even when you learn the product rule, you would not want to do it with the product rule. It's easier to do it this way. So g prime of x, we're going to now begin to start doing this stuff in our head. So what you can do here is, if you want to, since 2 is a constant, you bring down the 4 and multiply it to get 8, and then the exponent goes down 1. So you can just do that in your head. Same thing on the next one. The minus comes down. 8's a constant. 2 times 8 is 16. That becomes x to the first. Exponent goes down 1. This is what I call a linear term, and I'll keep kind of reminding you of this. The slope of a line is the number in front of x. Therefore, the derivative of 4x is 4. So the answer to the problem, and you could do this totally in your head after you multiply it out, is 8x to the third minus 16x plus 4. So that is your official derivative. Okay? Multiply stuff out first. That's what you want to do. Okay, same thing applies to the next problem. I would just, do the FOIL on this. Do the distributive property. Students are used to calling this FOIL. It's really the distributive property. You're doing x times x, which is x to the second, and then you're doing x times 6, which is plus 6x. That's what you're taught the first and outside term. It's the distributive property is what it is. Then you distribute again. So you do negative 5 times x is negative 5x. Then you do negative 5 times 6 is negative 30. That gives you what you call the inner and last terms like that. You do have two like terms, so put that together. So this would multiply out to give x to the second plus 1x, or just x, minus 30. Now that you got it multiplied out, you can do the derivative pretty much in your head. So this goes like this. Power rule here would be 2x to the first. That's a linear term, so what's the derivative of 1x? Just like this is 4, this is 1. What's the derivative of 30? 0. Now, so you don't have to write that stuff out. You can just do this in your head. So the derivative is 2x plus 1. Okay, but multiply it out first, then do the derivative. That's what we're going to do on each of these situations. Okay. Next two problems, we'll do the same kind of idea. Multiply it out. Now, this is not really FOIL. It's the distributive property. But, hey, FOIL is the distributive property. All right, so what we do here is we multiply the 2 by everything first. So we do 2x times x to the second. Remember, that's an x to the first. So that would be 2x to the third. Then 2x times 4x would be negative 8, x to the second. And then 2x times 9 would be positive 18x. So you're just distributing. Okay, then you repeat and you go this way like that. You distribute that stuff out. So this will go like this. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is positive 12x. And negative 3 times positive 9 is negative 27. You got like terms, okay? So it looks like the x squareds are like terms. They go together, and the x's go together. So you want to do that before you do the derivative, probably. So we have g of x equals 2x to the third minus 11x to the second and plus 30x minus 27. Okay, so again, I'm just multiplying that stuff out, get everything worked out, and now we can do the derivative. So g prime of x, just start doing this in your head. The 2 is a constant. You can either write it down or you can do this. Bring the 3 down. 3 times 2 is 6. Exponent goes down 1. That's 6x to the second. Next one, same way. Bring the exponent down. That will be 22x to the first. This is a linear term, so its derivative is 30. That's a constant. Its derivative is 0. So you can write the derivative g prime of x is equal to 6x to the second minus 22x plus 30. Multiply, then do the derivative. So you're going to be doing, of course, a little algebra as you go through. Calculus is full of algebra. Okay, I'm going to do exactly the same thought process on this. Do a distributive property. So we're going to do this times this. So we're just doing square root of x times square root of x. Then we do the square root of x times 2. So you get 2 times the square root of x. Little fundamental properties here. If both things are under a radical, then you can just put it together in one radical, and x times x is x squared. The 2's not under a radical, so it's best to just put it in front. So that's plus 2 square root of x. And then what's the square root of anything squared? That's itself. Okay, so that's x. That's a fundamental thing that you've learned before. And then before we do the derivative, we have to change this to x to the 1/2 power. Now we're ready to do the calculus, see? Okay, so now we just crunch out the derivative. So the derivative of x, that's a linear term. The number in front is 1. Same thing here. That's a constant. Write it down. Do the power rule. That's 1/2. X to the 1/2 minus 1. So I use 2 halves. So this would be 1 plus 2's cross out. And then that would be x to the negative 1/2. That's a derivative. That's an okay answer, actually. That would be 1 plus 1 over x to the 1/2. But remember I said if your problem has radicals, ultimately I'd like your answer to have radicals. So the answer would be 1 plus 1 over the square root of x. That would be as far as you would need to take that. And you need to go that far. Okay? Okay. So pause here and look over what I just did if you need to. Otherwise, I'll have you go to the bottom of the page and complete these 3 problems, okay, and see how you do. Okay, so take a look, see if you got what I got. And every one of these things you should multiply out first. So distributive property on the first one, negative 2x to the 13th. So you have 2 negatives there, so you have plus 2 times 1/2, x to the 4th. Okay, you're adding exponents. And then minus 40, x to the 3rd. Step 1's just due to the algebra. So when you multiply it out, you should get negative 12, x to the 3rd, plus x to the 4th minus 40, x to the 3rd. Okay, then it's just kind of your calculus. So power rule. Bring that down, multiply by 12. That would be negative 156, x to the 12th. Plus 4x to the 3rd minus 120x to the 2nd. That's what you should get. Number 2, multiply it out first. I'm going to show you 2 ways on this. So I went ahead and FOILed it. When you FOIL it, you get this. If you didn't get that, you want to make sure you see what your mistake was. Then when you do the calculus and do the derivative, this would be 2 times 4, or just 8x to the 1st. This is a linear term. Its derivative is 20. This is a constant. Its derivative is 0. So you get 8x plus 20. Not everybody knows this. A lot of you probably do. But I think as a calculus student, I find it important to start doing this kind of problem just in your head. So the shortcut goes like this. First thing you do is you just take the 2x and you square the whole thing. Then you take the 5 and you square it. Then you multiply these 2 terms together, but then you double it. Okay? And then, since this is a plus sign, everything's going to be positive. So this would be 4x to the 2nd plus 20x plus 25. If you don't know that, practice that. Look up, on YouTube or Google, shortcut for squaring a binomial. We call that squaring a binomial. Okay, that just saves you a little time to do that then. Okay, so you get 8x plus 20 as your derivative. The next one, when you FOILed it out, you would get x plus 3x to the 1/2 minus 10. You want to check over my FOIL. Sometimes students got to brush up on this. And you don't have to write every step. The better you are at this, the more you can do in your head. So the first term is just radical x times itself. Outside term is minus 2 radical x. Inside is plus 5 radical x. Last term is negative 10. This becomes square root of x squared, which becomes x. These are like terms, so negative 2 plus 5 is 3 radical x minus 10. Sometimes students haven't done this in a long time and need to brush up. Those are like terms. So again, if I'm going to do the derivative of a square root, I need to change it to a 1/2 power. All right? So this will go like this. The derivative of the linear term is 1. This 3 is a constant. Bring it down. 1/2 x to the 1/2 minus 1. Derivative of 10 is 0 since it's a constant. So you'll get this. Change the negative exponent to positive. Change it back to a radical, so that would be the answer. Okay? All right, pause if you need to look over what you just did there. That's the best way to do these problems, by the way, is just multiply it out and then just do your standard derivative rules. Okay? Okay, I want to go through quotients and a few applications on this. All right, so you're going to learn what we call the quotient rule in calculus. We're not going to do that yet. Anytime you see a fraction, first of all, it's not right to do this. You couldn't just do the derivative of that numerator. If you did, you'd get 24x to the second minus 8x plus 1. If you did the derivative of the bottom, you'd get 2. Can't do that. It doesn't work. All right, so the only choice you have is to do this. At this stage in the class, you just need to split this fraction up. So you're going to have 8x to the third over 2x minus 4x to the second over 2x plus x over 2x. Split it up. Okay, then simplify, then do the derivative. Okay, so this will work out kind of like this. Okay, you can simplify. 8 over 2 is 4. If you're doing x to the third over x to the first, okay, I like to just remind people of stuff over at the side. That's x squared. Or you can subtract the exponents to get x to the second power. So that gives 4x to the second power. Next one, 4 over 2 is 2. X squared over x is x times x over x, so that's x. Or subtract 2 minus 1 to get x to the first. The next one, the x's divide out, so you're going to get the constant 1/2. Okay, now you're ready to take your derivative. So what you would get is 8x to the first. This is a linear term, so that's minus 2. That is 0. So the derivative would be h prime of x is equal to 8x minus 2. Okay, so that's how you do your derivative. All right? So simplify, then do the derivative. Okay? And by the way, if you tried to do it this way, it wouldn't work. Okay? We just did the derivative of top, derivative of bottom. That's not the same as this. And it won't simplify to being the same, so it just doesn't work. Okay? The next problem, you have to factor. Now, you can't do this. I see students do this kind of thing all the time. This is the kind of thing that drives, math professors a little bonkers. But it's understandable because, you're in a learning process. And you learn from your mistakes. You always do. Students a lot of times want to just do this and get t to the third. Then they just want to cross that stuff out. You can't do that. You can't do it. It doesn't make any sense to do that. So the only thing you can do is factor this. And the factoring of this numerator, this is what we call a difference of two squares, which you encounter in this class a lot. So you draw two parentheses. That would be t to the second, t to the second. Then you do 1 and 1. And anytime you factor a difference of two squares, the signs go plus and minus. Want to make sure you're totally on top of your factoring in this class. If you need to brush up on factoring, Google and look at videos, do some practice problems and stuff. Okay, the denominator just comes down, and then what happens is this factors further. This doesn't. A sum of two squares does not factor, and it never will. It won't factor through real numbers. It'll factor through complex numbers. We don't need to really go there, though. So this would be t to the second plus 1. This is another difference of two squares, so when you factor what I have highlighted in yellow, that would go t plus 1, t minus 1, all over t minus 1. All right, so what would happen is that would divide out, and you would be left with t to the second plus 1 times t plus 1. So you have to simplify first, okay, until you learn the quotient rule. At the end of this section, we'll briefly learn the quotient rule, and this problem could be done that way. We're not ready for that yet. Well, what do? You need to multiply this out. Go ahead and FOIL this out. So t squared times t is t to the third. Outside term, t squared times 1 is t squared. Inside term, 1 times t is 1t. Last term, 1 times 1 is 1. Now you can do your derivative. So g prime of t would go like this. So we say g prime of t is equal to 3t to the second plus 2t plus 1. So I'm kind of beginning to start doing those derivatives more in my head. That's what you want to do. All right, so you got to multiply it. You got to simplify before you do the derivative. That's a general rule of thumb, too. If I give you a function to simplify that, to do a derivative of, see if you can simplify it first. Okay? Okay, part C, kind of an interesting problem. You can't just do the derivative of top divided by derivative of bottom. That does not work, and it never will. Well, it might work in some cases, but the vast majority it ain't going to work on. Okay, so we have this. What we're going to do is rationalize the denominator. This is algebra background stuff. So you want to get rid of the radical. You multiply by what's called the conjugate, which just means radical x, radical a, opposite sign. So instead of minus, put plus. And to keep from changing the problem, you have to do that. Okay, we're going to simplify this, then do the derivative and see what happens. Okay, so this goes like this. You have to, now I'm not going to FOIL the numerator because my goal is that something might cancel. So let's just bring down the, write down that numerator for now. Now let's multiply out the denominator. You want to do that because something very special will happen. Nobody's home. Later. Salespeople. All right, so we do this. First term is square root of x squared. Outside term is plus square root of xa. They're both under a radical. That's why I put it all in one radical. Inside term's the same thing, except it's minus. It doesn't matter what order you put that in. They're still the same term. And then the last term is minus square root of a squared. Okay? So I get this. We're left with x minus a times square root of x plus square root of a. Now notice what happens. Those cross out. This becomes x minus a. Isn't that beautiful? That crosses out. Okay, I knew something like that was going to happen. So we get the square root of x plus the square root of a. Now we hadn't done any calculus yet. We just simplified that. But now we should be able to do a derivative pretty easily. So we're doing the derivative of y. You can either write y prime or you can write dy over dx. Well, you would want to write this as x to the 1/2. And you could write it as a to the 1/2 if you want to, but you don't really have to. I'll explain why. So this derivative by power rule would be 1/2 x to the 1/2 minus 1. What do you think the derivative of this is? 0. See, I even told you a is a constant. So that's 0. So the answer to the problem is dy over dx would be 1 over 2 x to the negative 1/2. So I'm going to change it back to a radical. So I've got 1 over 2 x to the 1/2 So that's 1 over 2 radical x. Who would have thunk? All right, so that's what we get there. All right, simplify first. That's real crucial in this, and you got to get really skilled with your algebra in this class. You have to. There's no escape. Okay, pause here if you need to and look over things and, take a little time to process what I did, look through the steps and so forth. Otherwise, I want you to just move on down to the bottom, and I'll give you a little time to crunch out these problems that are very similar. So you want to basically simplify first. Number 2, so you got that conjugate, kind of like I did on the last problem. Number 3, you got some factoring. The key on that is to factor. Number 1, you generally split this up. Okay, so go ahead and work on that a little bit and then resume the video and see if you get the same thing that your professor does. Okay, so let's look over this and see how you did. Here's my 3 answers. And number 1, I split it up. So I just do 15x to the third over 5x, 10x squared over 5x, 8 over 5x like that. Now the algebra on this is, of course, 15 over 5 is 3, 10 over 5 is 2, and then, this part right here is real crucial. You can't do the derivative of this until you bring that x to the top to get this. So actually the first thing you have to pay attention to is, did you get this? Now you're ready to do the derivative. So that's the simplification problem like that. Okay, now the derivative of 3x squared is 6x. Derivative of 2x is 2. Then you're ready to do the power rule. So it's just minus 8/5 x to the negative 2. All right, then all I really need to do is just bring that down. So I write it as a positive exponent. So that's the best way to write the answers like that. Number 2 is a good exercise. You're going to be doing this type of thing here and there during the class. Multiplying by constants to get rid of radicals is a pretty common thing that you do in calculus. So multiply by the conjugate is what you should have done. I don't do anything with the numerator. I just leave that alone. But when I multiply out the denominator, I get square root of t squared for the first term, plus 1 root t for the inner, or the outer, minus 1 root t for the inner, and then negative 1 for the outer. That crosses out. Square root of anything squared is itself, so you get this. So it worked out a lot like the example I did before. You end up with this. So actually, after you simplify, you get this. Now to do the derivative, just change the square root of t to t to the 1/2. Then do your derivative, and you can see how I did my derivative. Okay. Right, number 3, factoring skill. Start by taking an x out. Don't forget that you look for common factors first. So pull an x out, you would have this. Pull an x out of the bottom, you would have this. X's divide out, and then this is a trinomial that factors. So the factoring of x squared minus 6x plus 8 is x minus 4x minus 2. That crosses out. Again, after you simplify, you're left with that. And then the derivative is 1. Okay, remember this is a line. Y equals x minus 4 is a line. And the slope is 1. Okay, so that derivative, once you got it simplified, was 1 on that. So all these problems have in common the quotient. You have quotients. Try to simplify first if you can. You can't always do that. And if you can't, then we have a rule that we're going to learn called the quotient rule. Okay, so let's see. We're going to run through a couple of other things on here. I think I'm going to go ahead and post this video here and just kind of do the applications in part 3. All right, so this is a good place to kind of stop and post a video. So good luck.